All right, we were just talking about inverses, talking about how on the linear function, let me backtrack here, on the linear function, when I had an output, in this case it was a 3, and I worked backwards to try to find the input, we got the number 4, and it was the only one possible. Okay, on the parabola though, when I had the output of 4 and I try to work backwards, I get a positive 3 and I get a negative 3. I have 2 outputs. So the question is, well, or 2 inputs. Question is, well, which one of those was the one that I wanted? Either one would work. The difference is that this one is not a one-to-one function like the linear one is. Okay, so difference between these is that the first one, the linear one, is a one-to-one function. What a one-to-one function means is that for every input there's one output. That's what every function is. But it also means for every output there's one input. For quadratics that's not necessarily the case, and for the trig functions that's also not the case. Okay, so functions that are not one-to-one, a given output can have multiple inputs. So here is the sine graph. F of x equals sine x, or y equals sine x. If you were to graph the whole thing, of course it keeps on going over and over and over again. It's called periodic, which means that it keeps repeating itself over and over again, and it looks like this wave. Okay, so the question is, well, why does this, or how does this show me that any given output could have different inputs? We'll take a look at these 2 points. Both of them have the same y value of, this is 1 right there. That has a value of 1 if we were to stick in the x value, and so does this one. Okay, they have the same output, but they have different inputs. As a matter of fact, there's an infinite number of these things. So if I were going to work backwards to try to find an angle measurement when I knew the answer, when I knew the ratio, there's a whole bunch of angle measurements that could possibly work. And that's a big problem. Okay? So to find an angle measurement in a right triangle, given any 2 sides, we want to use the inverse of the trig function. But before we define it, we have to say what interval it works on. We have to restrict it. So let me look back at this example. So for example, on the sine, if I only chop it off between here and here, then obviously this one must have been the answer that I wanted. If I only pick values in this spot between these 2 values, then I would be good. Okay, so let me explain on the parabola. On the parabola, the equation is y equals x squared. For the inverse, remember it flips it across the line y equals x, so it looks like a sideways parabola, and the equation would be y squared equals x, and we want to solve that for x. Y would be equal to plus or minus the square root of x. And that's a problem because it's not a function. Okay, so what we could do is we could restrict the original one and only talk about this half of it, say the positive half, where x is greater than or equal to 0. In that case, when we take the inverse, the negative one is gone, and all we would have is the top part of this graph. And then we've solved our problem. We have to do the same thing for inverse trig. Okay, so for the sine of, remember this is sine of an angle is equal to a over b, opposite over hypotenuse, then that angle measurement is, the way you read this is the inverse sine of a over b. As long as this angle measurement is between negative 90 and 90, then we're okay. For cosine, the same thing, as long as we're between 0 and 180 degrees. And then the tangent is defined just like the sine between negative 90 and 90. This is supposed to be all real numbers. Okay. So again, sine negative 1 means the angle whose sine is x, or inverse sine, or you sometimes see it written like this, the arc sine of x.